Okay, for topic two, we're going to look at graphing systems of linear inequalities. So at this point, you already know how to just graph a linear inequality, just a singular linear inequality in two variables. So we need to take that idea and then merge it with this world of systems of inequalities, okay? Or systems of equations. Now, when you're graphing a system of linear inequalities, you need to understand that that is a situation where you have so you have a system of linear inequalities in two variables. It consists of two or more inequalities that must be satisfied simultaneously. You might want to think of that as solved because we're looking for a set of ordered pairs that satisfies both inequalities at the same time. So you're kind of looking to solve them at the same time. Okay. Now, the actual solution to a system of linear inequalities is the set of all points, so the set of all ordered pairs x, y, that satisfy each inequality in the system. So what ends up happening is you kind of have to graph two inequalities sort of at the same time. So not really at the same time, but on the same Cartesian plane or the same coordinate plane. And you want to look to see where those shaded regions overlap each other. And that's where we have the solution to this system. So it's a little bit different than just a system of equations where you're looking for just that single point where the two lines intersect. Here we're looking for a whole entire interval of solutions. So we're looking for this overlap in shaded regions. Okay. Now the steps to solve a system of linear inequality, sorry, is graph each inequality on the same coordinate plane. Shade the region that satisfies each inequality. So this can get a little bit messy, okay? So take your time with this. Don't do this in pen. Please don't do this in pen. Do this in pencil because the chances of needing to erase something are pretty high here. Okay. And then what I do is I graph each inequality and I'll just very gently make a few marks to indicate where I would shade. And then after I have both of them graphed, I look to see, okay, where do those shaded regions overlap? That's going to be the majority of my solution. Okay. And then you do need to use caution with the actual point where the two lines intersect. The only time you include the point where the two lines intersect is if both inequalities have the or equals to inequality symbol. If you have even just one strict inequality where it's just less than or just greater than, no or equals, then you can't include that point because it doesn't satisfy both inequalities. And then you do want to look at the point of intersection. So that's kind of what I'm saying. So like right here. Okay, so you look at the point of intersection. If either inequality is what we call a strict inequality, the point is an open circle. That means you cannot include that point because it doesn't satisfy both of the inequalities. If both of the inequalities have an or equals to, then you want to use a closed circle because that point does satisfy both inequalities. So just use a little bit of caution there. Okay, so for example, two, the directions just say graph each inequality. Let's go ahead and get started. I think I've got enough room. Okay, so for part A, we have y is greater than 2x minus 3 and y is less than or equal to negative x plus 6. So what I'll generally do is I'll graph the two lines in different colors just to be really, really clear when I'm teaching. So we'll do the first inequality in black ink, okay? So for y is greater than 2x minus 3, the good news is this has already been solved for y. So we can jump right to the slope and the y-intercept, and if we have to use a solid line or a dotted line, and then which direction we shade. So for the first inequality, we have a slope of 2. Remember the coefficient of x, as long as you're solved for y, the coefficient of x is always the slope. And I'm going to put that as 2 over 1. The y-intercept, as long as you're solved for y, is always the constant, so the y-intercept is negative 3. We have that y is just strictly greater than, so that tells me I'm going to connect with a dotted line, and then we'll test a point to see which half plane we shade for this inequality. So let's go ahead and graph this one in black. So I want to plot my y-intercept, which is negative 3. From there, I need to apply my slope. And remember, we can apply a slope in two different directions. So since my slope initially is positive, I will go up 1 and to the right 2. So I would go up 1, 2, or I think I said I would go up 2 to the right 1. I think I said that backwards. So we want to go up 2 and then to the right 1. And then up 2 to the right 1. We could also, if you wanted to, since we have m is positive 2 over 1, like we just did, we could go up 1 or up 2 and then to the right 1. You could also think of this as negative 2 over negative 1, and you could go down 2 and then to the left 1. So if we go down 2 to the left 1, we're still on the line. We could go down 2 to the left 1, we're still on the line. Okay, so you want to plot 2 or 3 points, and then remember we're connecting with a dotted line. That means the ordered pairs on the actual line are not part of the solution. Okay? Now let's test a point. So I always test the origin unless my line goes through it. You can test literally any ordered pair you want as long as it is not an ordered pair on the line. But the easiest point to check is always going to be the origin because you just plug in zeros. So let's test 0, 0. Okay, now notice 0, 0 is up here. Okay, so if that point, when we plug it into our inequality, gives us a true statement, that tells me it's part of the shaded region, and I want to shade the half plane that contains the point 0, 0. If we get a false statement, that tells me it's not part of the solution set, and I want to shade the opposite half plane. So we're going to go to the original inequality. So we have y is greater than 2x minus 3. I'm going to replace x and y with 0. And when I simplify, I get 0 is greater than, and then I have 2 times 0, which is 0, minus 3, which is negative 3. So we have 0 is greater than negative 3, which is true. So that tells me that I am going to shade up here. And I'm just going to put a couple of gentle marks so I don't forget that I shade above the line. Okay? Now for the next line, let's shade, or let's do it in this blue color. Okay? So luckily, again, we're already solved for y. So the coefficient of x is my slope. So my slope is -1. And I'm going to go ahead and just put it over 1 because I need a very specific rise and a run. Okay. My y-intercept is 6. And then because of this or equals to inequality symbol, we do want to connect these points with a solid line. It means that the points on the line are part of the solution set. Okay. So let's go ahead. We need to find 6 on the y-axis. So 1, 2, 3, 4, 5, 6. We want to apply our slope, which is going to take us down 1 and then to the right 1. So down 1 to the right 1, down 1 to the right 1. And then just like we did before, we have a slope of -1 over 1. So that told us to go down and to the right. I could switch places with the negative, and I could write this as +1 over -1, which tells me to go up and then to the left. So I could go up and then to the left, up and then to the left. We're still on the same line. So you can always apply your slope in two directions. Okay. Now we want to connect with a solid line. And then we need to test a point. So we can test the origin again because it's not on the physical line. So we're going to test 0, 0. Okay, so I'm going to go back to my original inequality, which is y is less than or equal to -x plus 6. Anywhere I see an x and a y, I'm going to plug in zeros. So I have 0 is less than 0 plus 6. So I get 0 is, well, less than or equal to 0 plus 6, which is 6. And this is again true. So this tells me this point 0, 0 is part of my solution set. So I would want to shade below the line. Okay. Now, if we think about this, we shaded above the black line. We shaded below the blue line. So we want to finish shading in this region right here. But we have to be very mindful of the actual point where the two lines intersect. And since we do not have 2 or equals to inequalities, we want to make sure that we have a nice open circle right here. We cannot include that point in our solution set because it does not satisfy both inequalities. Okay? So that is the first line, or the first system. Let's look at part B. Let me scoot this out of the way. Okay, so for part B, we have 3x plus y is less than 6, and then we have x plus 2y is greater than or equal to 2. So we're going to do the same thing. We're going to use two different colors to kind of help us keep track of these lines. Okay, so for 3x plus y is less than 6, I want to solve for y. To do that, I want to subtract 3x. So 3x minus 3x, they just cancel, they become 0. So I'm left with y is less than -3x plus 6. So in this case, my slope is -3, and I'm just going to put that over 1. My y-intercept is 6. I have a strict inequality. This is just a flat out less than. There's no or equal to, so I want to connect my points with a dotted line. So let's go ahead and graph this one, and then we'll test a point, and then we'll go back and get the second line, or the second inequality. So we want to plot 6 on the y-axis. So 1, 2, 3, 4, 5, 6. Okay. And then I want to apply my slope, which is -3, 1. So I'm going to go down 3 to the right 1. And then I could also go up 3, but then I'd have to go to the left 1. So I've got my points here. I want to connect them with a dotted line. So it would look something like this. And again, we want to test a point. So I like to test the origin unless my line goes through the origin. So I want to test this point right here. So let's see, that's 0, 0, of course. So we want to test 0, 0. So my original inequality was 3x plus y. Anywhere I see an x and a y, I'm going to replace them with 0. And we want to see if that is less than 6. Well, 3 times 0 is 0. 0 plus 0 is 0. And 0 is less than 6. This is true. So that tells me the ordered pair 0, 0 is part of my solution set. So I'm just going to kind of make a few gentle marks there to make note of that. Okay? Now, for the second inequality, we have x plus 2y is greater than or equal to 2. Okay, we want to solve for y again. So I would subtract my x from both sides. X minus x is 0. 0 plus 2y is 2y. And I've got 2y is greater than or equal to negative x plus 2. And then I want to divide each term by 2. So I'm going to divide each term by 2. Well, 2 divided by 2 is 1. And so we get 1 times y, and then y is greater than or equal to, well, negative x over 2 is negative 1/2 x, and then 2 over 2 is just 1, okay? Now, as soon as we solve for y, we can get the slope and the y-intercept. So my slope here is negative 1/2. My y-intercept is 1. And I have an or equals to on this inequality, so I do want to graph this with a solid line, okay? So we want to plot 1 on the y-axis, and then I'm going to go down 1 to the right 2, down 1 to the right 2. I could also go up 1 to the left 2. So I get something like this. And then we want to test a point. So again, we can test 0, 0. Our line does not go through 0, 0. So let's see, the original inequality, I have x, which is 0, plus 2 times y, which is 0, which is greater than or equal to 2. So let's see, I have 0 plus 2 times 0, which is just 0. So I have 0 is greater than or equal to 2, which is false, okay? So that tells me this point right here, the origin is not part of the solution to the second line. So that would tell me to shade above it. So I want to shade here in between these two lines. So this little region right here. And then we have to talk about the actual point, okay? Now, the actual point where the two lines intersect, the only time you can include it is if both of your inequalities are an or equals to inequality. In this case, they are not, so we want to put a nice open circle right here. Let me see if I can erase without, let me fix the line. And then I want to put a nice open circle right here, okay? The only time you put a closed circle there and include that point is, again, when both lines have an or equals to inequality. All right, let's look at part C and D. So for part C, we have y is greater than x minus 1, and then just x is greater than 5. So for the first line, we'll again use black, and then for the second one, we can use blue. Okay, now for the first line, we have already solved for y, so we don't have to do any work there. And the coefficient of x is 1. So that tells me my slope is 1 over 1, and then my y-intercept is negative 1. Okay? And I have the strict inequality, so I do not have the or equals to, so that tells me to connect with a dotted line. So let's see, we get negative 1 on the y-axis, and then my slope, I go up 1 to the right 1, up 1 to the right 1, or I could go down and to the left, down and to the left. Either way, I'm on the same line. We connect with a dotted line, and then we want to test a point. So let's test again the origin. We're close to the origin, but we don't quite go through it, so we can test it. My original inequation, bless my heart, my original inequality is y is greater than x minus 1. So anywhere I see an x or a y, I'm going to replace it with a 0. So I get 0 is greater than 0 minus 1. So I have that 0 is greater than negative 1, which is true. So that tells me my solution is on top of the line because the ordered pair 0, 0 is right there, that tiny little spot, okay? Now we have to talk about x is greater than 5. When it comes to these equations, or in this case, inequalities, where you just have one of the two variables, you have to be really, really careful with these. You know it's either going to be horizontal or vertical. So you kind of have to ask yourself, well, which variable do I have? Well, in this case, we have an x, but we don't have a y. Without a y, I can't touch the y-axis. Okay, so I can only touch the x-axis. I have to be parallel to the y-axis, so that means this is vertical. Okay, and it is a vertical line that goes through 5 on the x-axis. Okay, and because it's a strict inequality, I want to use a dotted line again. So let's find 5. So from the origin, we go to the right. 1, 2, 3, 4, 5. We want to graph a dotted line. Okay. And then this says 5 is greater than. So with a vertical line, you don't really shade on top or below a line. You shade to the left or to the right. And for greater than, you want to shade to the right. So that tells me this little tiny region right here is where our solution is going to live. And then again, we have the strict inequalities for both lines. So the point where the two lines intersect, we need to use a nice open circle. Okay? Finally, part D. So part D, the good news is both of the inequalities are solved for y, so we don't have to do that part. But we got a good bit of work ahead of us, so let's get to it. So we have y is greater than or equal to 2x minus 3. So we'll use black for this inequality here. So the slope is always the coefficient of x as long as you solve for y. So our slope is 2 over 1. My y-intercept is always the constant as long as I've solved for y. So the constant here is -3. And we do not have a strict inequality. We do have the or equals to, which tells me we want to connect with a solid line. So let's go ahead and graph this one. We've got -1, 2, 3 on the x-axis. So that's my y, or ooh, we have -3 on the y-axis. So that's my y-intercept. And then I need to apply my slope. And since it's +2 over 1, I'm going to go up 2 and then to the right 1. So up 1, 2 to the right 1. Up 1, 2 to the right 1. I could also go down 2, but if I go down, I have to go to the left. So I want to connect these with a solid line. And then we're going to test a point to make sure we know which side to shade. Okay, so my line does not go through the origin, so I can just test 0, 0. And when I do that, I've got y is greater than or equal to 2x minus 3. Anywhere I see an x or a y, we put in a 0. So I get 0 is greater than or equal to 2 times 0 minus 3. Well, that gives me 0 is greater than or equal to, well, 2 times 0 is 0, and then 0 minus 3 is -3. This is true. 0 is greater than -3, so we want to shade above the line. Okay? Now for the second line, or the second inequality, we'll use blue again. So for the second one, we're already solved for y, so we can go ahead and figure out what the slope and the y-intercept are. So my slope is the coefficient of x since I'm solved for y, so it is also 2 over 1. And my y-intercept is 1. And then again, I want to connect with a solid line. Okay? So let's see here. We want to plot 1 on the y-axis and then go up 1, 2, and then to the right 1, up 1, 2, to the right 1, or we could go down 2 to the left 1. Either way, we end up with this situation. Now, you have to be kind because I'm not using a ruler here. What I hope you notice about these two lines is they're actually parallel. So these two lines are parallel, which means they never intersect. The lines themselves never intersect. But we could potentially have a solution depending on the shading, okay? So we still want to test the shading for the blue line because if we shade below the blue line, then we're going to have overlap of our shaded regions. So let's go ahead and test. Again, it looks really close to the origin, but it's not actually going through the origin. You know you have a line that goes through the origin when you have like y equals ax, but there's no plus or minus a constant. So we're good here. We can test the origin. So I've got y is less than or equal to 2x plus 1. Anywhere I see a y or an x, I'm going to plug in a 0. So I get 0 is less than or equal to 2 times 0 plus 1. Well, 0 is less than or equal to, let's see, 2 times 0 is 0, but then 0 plus 1 is 1, and this is true. So that tells me this point right here, which is just barely below my line, is where I'm going to shade. So I'm shading on top of the black line, below the blue line. So we're shading that little region right between these two parallel lines. Okay, so that would be your solution for part D. Okay, so take your time with these. Don't try to rush through them. It's easy to make a mistake, as you all obviously know. Be cautious with the dotted lines, the solid lines, shading above, shading below. Make sure with these in particular, it's especially easy if you, I think it's easiest if you solve for Y and use that method for graphing. Okay. So there you have it. Just take your time and please don't use pen when you do this on paper. This is definitely a time for pencil. All right.